Yeah, so good afternoon, everyone. So we all welcome you to the first technical session. So this technical session is the climate change and early warning. Uh, myself and Dr. Shiromani Jayawardena will be sharing the session, and Dr. Shiromani is the Director Forecasting and Decision Support from Meteorological Department of Sri Lanka. And welcome, Dr. Shiromani, to the session.
Thank you, Dr. Chandana. Dr. Chandana Sirivardhana is my co-chair today, and he's a well-known academic in the field of disaster risk management and communication, and also a senior lecturer in the Department of Civil Engineering, University of Morato, as well as Honorable Secretary of ADRIM, Association for Disaster Risk Management Professions in Sri Lanka. Welcome you, Dr. Chandana.
Thank you very much. And I forgot to mention that you are the chief editor of this our professional organization for disaster risk management. So shall we move on to the first presentation? Then Dr. Shiromani.
Yeah. I would like to welcome Mrs. R.D. Hettiarachchi, our first presenter from the Open University of Sri Lanka, to present the impact of Pacific Decadal Oscillation on Southwest Monsoon rainfall over Sri Lanka and monsoon-ENSO relation. Over to you, Mrs. Hettiarachchi.
Good afternoon. For the distinguished gathering, listen to my presentation. I am Renuka from the Open University of Sri Lanka. I will present some of my findings in my research work. Impact of Pacific Decadal Oscillations, PDO, on Southwest monsoon rainfall over Sri Lanka and monsoon-ENSO relation. Why it is important to Sri Lanka? As a country, we need long-term decisions to adapt for the impact of climate change. PDO has a period of 20 to 30 years. It modifies the sea surface temperature of the mid-latitude Pacific Ocean, which exerts its influence on the other regional climates. What are the scientific objectives of my study? An examination of possible influence of the North Pacific sea surface temperature and provide detailed space-time structure for the relation between Southwest monsoon rainfall and PDO. The second one, the influence of PDO on Southwest monsoon rainfall ENSO relation. The data used: 50 years monthly rainfall data of 21 rainfall stations in Sri Lanka, obtained from the Department of Meteorology of Sri Lanka. La Nina and El Nino episodes from the NOAA Climatic Prediction Center. The vector winds at 3 different pressure levels from NCEP-NCAR reanalysis data set. The methodology used: cool and warm regimes of PDO were obtained from the graph of time versus PDO index. There were 3 cool and 2 warm regimes of PDO during the years 1961 to 2000 period considered for the study. La Nina and El Nino years were categorized using ONI index. monthly rainfall anomaly composites were calculated for southwest monsoon period for each selected station. If the calculate composite percentage is less than -10%, such a station is considered as a dry station. If the calculated composite percentage lies between -10% and +10%, such a station is considered as a neutral station. And if it is greater than +10%, the station is considered as a wet station. Results obtained were plotted in the Sri Lankan map with the legend dry stations, blue circles, neutral stations from gray crosses, wet stations, red triangles. From the plotted maps, we can see that approximately 67% of the selected stations receives enhanced rainfall in warm La Nina episodes. And 60% of the selected stations receives deficit rainfall in warm El Nino episodes. In the analysis, vector wind and vector wind anomaly maps were constructed at 3 different pressure levels, 850 hectopascal, 500 hectopascal, and 250 hectopascal for different regimes of PDO during La Nina and El Nino episodes. It can be seen that prevailing circulation conditions in the region around Sri Lanka were favorable for southwest monsoon rainfall in La Nina episodes during cool regimes of PDO. During El Nino episodes, in the warm regime of PDO, circulation patterns are not in favor for the southwest monsoon rainfall over Sri Lanka. From the study, we can conclude that the relationship between southwest monsoon rainfall and ENSO event seems to be modified according to the regime of the PDO. Northern and equatorial Pacific Oceans plays an intermediary role for this modification. But a detailed analysis with more rainfall data is suggested to examine how southwest monsoon rainfall variations are associated with PDO regimes in different ENSO events. The analysis provides a useful reference of when and where the PDO regimes have significant impact on southwest monsoon period in Sri Lanka. This information can be used to enhance the skills of forecasting southwest monsoon rainfall in Sri Lanka. Thank you for listening me.
Thank you, Mrs. Settiarachchi, for wonderful presentation. Now the session is open for questions and comments. So please use the chat box for write down your questions and comments. Meanwhile, I'll ask one question from Mrs. Settiarachchi. So I have seen, especially recent years, the fluctuation of warm and cold phases more frequently, even though it says decadal oscillation, even every 5 years we can see the fluctuation from cold phase to warm phase like that. So what is the reason behind that?
The reason may be the change in climate. Now we can see very frequent change in climate.
Okay, thank you. And have you seen any kind of like frequency of occurrence of El Nino and La Nina event with respect to the cold and warm phase of PDO?
There is no such difference. But the thing is, now early days, it has a long period. Now 1948 to 79, we have cold regime, which is 29 years long.
Mm-hmm.
But it gradually decreases actually. Now in 1998 to 2002, it becomes 5 years. Then again, but in 2008 to 2015, it increases to 8 years. But anyway, we can see that there is a drastic decrease, isn't it?
Yeah.
In warm also the same thing. Now, frequently, there is no difference in gaps actually. Almost all are less than, say, 6 years.
Okay, thank you, Ms. Settiarachchi. I think time for us to move for the next presenter, Dr. Chandana.
I think, Dr. Shiromani, there is a question
Okay.
from
Yeah,
Tushar
yeah.
Pradhan. So the question is, with this research, are you able to predict these extreme events? And could this info be useful for climate impacts?
Yeah, Ms. Settiarachchi.
Yes, but we need to do a more detailed study to go such a to have a such prediction.
To validate the model and all.
Yeah, yeah.
Yeah, other thing I think just this study they didn't use the extreme events actually. So extreme events only the anomaly or that kind of thing. So okay, thank you for your question.
And also, Dr. Shiromani, we would like to welcome again everyone from Mexico to Australia, Philippines, Pakistan, Nepal. It's very, very nice to see like this kind of a cross section in this among the participants. So with that, we will move on to the next presentation. That is, the title is Study on Landslide Early Warning by Using Rainfall Indices in Sri Lanka. The presenter is Tomioki Wada. I think he's from Earth System Science Corporation Limited, Japan. Together with the co-authors are from National Building Research Organization, Sri Lanka. So, Wada-san, whenever you are ready, you can start the presentation.
Good afternoon. Thank you for your interest in this presentation. Our presentation title is Study on Landslide Early Warning by Using Rainfall Indices in Sri Lanka. This study is implemented by the International Cooperation Project funded by Japan International Cooperation Agency. The study members are from NBRO and JICA consultant. Landslides cause severe disaster damages in Sri Lanka. Around 63% of deaths and missing due to disasters was caused by landslides. This study focused on the improvement of landslide early warning. Landslides are caused by these factors and triggers. Predisposing factors are topography, geology, hydrology, and other factors. Actual triggers of landslides are rainfall, snowmelt, earthquake, and others. In Sri Lanka, rainfall is the key trigger of landslides. When severe rainfall occurs, then soil water increases and shear strength decreases. As a result, landslides occurs. In Sri Lanka, NBRO issues landslide early warnings. These landslide warnings are issued based on real-time observed rainfall. Challenges of the current landslide early warning thresholds are uniform in the country, so regional characteristics are not considered into the early warning. Other challenge is effects of previous rainfall are not sufficiently considered in the warning. Approach of this study is following. Firstly, we collect the past landslide records and observed rainfall data, and we calculated new rainfall indices. Then we validate the effectiveness of these rainfall indices by using the past landslide records and discuss to determine the critical lines and thresholds considering regional characteristics of landslides. The collected data are past landslide records in Sri Lanka from 2014 to 19. In addition to that, 30 minutes observed rainfall times 3 are utilized for the analysis. Two rainfall indices are utilized on this analysis. One is working rainfall. The working rainfall is a total amount of current rainfall and previous rainfall which reduced depending on time. The working rainfall includes the effects of current rainfall as well as remaining soil water of previous rainfall events. Another rainfall index is soil water index. Soil water index was developed in Japan and utilized as an indicator of landslide risks and utilized to issue landslide early warnings in Japan. Soil water index is calculated by using a tank model, which is a conceptual runoff model. The soil water index indicates behavior of soil water, which cause landslides. The tank model simulates infiltration and runoff by using rainfall. Rainfall time series is inputted into the tank model and remaining soil water amount is calculated. Calculated soil water index and working rainfall were plotted on line scatter charts named snake curve charts. In addition to the rainfall indices, past landslide points are also plotted on that chart. X-axis of the snake curve chart is soil water index, and y-axis of the chart is 1.5-hour half-period working rainfall. A sample of snake curve chart is shown in this slide. This chart shows landslide risks due to heavy rainfall. In case of small rainfall, the calculated soil water index and working rainfall range is near zero, and there is no landslide record. On the other hand, in case of heavy rainfall, calculated soil water index becomes high, and if past landslide occurs due to that heavy rainfall, the past landslide record point is plotted on that chart. Then we can see the critical line which located between the landslide occurrence and no occurrence. In this case, we can assume the critical line or threshold of landslide occurrence is like this. In the right side of the chart means high risk for landslide due to heavy rainfall. These snake curve charts are calculated for 25 rainfall gauging stations using rainfall times these data, and critical lines for each gauging stations are developed considering regional characteristics. Calculated snake curve charts are shown in this slide. Red points are past landslides and orange points are past debris flows. Green points are past slope failure or cutting failures. Landslides and debris flows occurred under high soil water index condition, so it seems that soil water index is a good indicator for landslide occurrence. On the other hand, slope failures occurs even in less rainfall events, so there is a difficulty to predict slope failures by using these rainfall indices. In some rare cases, some landslides are also occurred in less rainfall events, which may be due to slow infiltration into deeper slip layers and slow soil mass movement. But frequency of these cases is relatively low, so soil water index is still good indicator for landslide occurrence in majority case. This purple line is 0.005 probability line of soil water index and working rainfall. These lines tend to show the boundary of landslide occurrence and non-occurrence. So there is a possibility to use these lines as a critical line. According to the analysis result, when landslides occurred, soil water index was significantly high. So soil water index seems to be a significant index of landslide occurrence. In case that the equal probability lines of 0.005 are determined as a critical lines of landslide occurrence, then 73% of landslides and debris flows can be predicted. On the other hand, only 38% of slopes and cutting failures can be predicted. Airshot ratio is around 3%. These results show that success ratio of landslides and debris flow prediction is high, so there is a possibility to improve the landslide early warning accuracy by using these rainfall indices. This figure shows the regional characteristics of critical lines. Critical lines in southwestern region tend to be higher compared with northern area. It seems to be an effect of severe rainfall caused by southwest monsoon. Conclusions of this study is shown in this slide. There is a possibility to improve the accuracy of landslide early warning in Sri Lanka by using the rainfall indices, considering regional characteristics. However, it is crucial to note that further accumulation of rainfall and landslide records is necessary to continuously improve early warnings. Thank you for your listening to my presentation.
Thank you very much, Vada-san. We can move on to the questions, and then in the chat window, there is a question. It's Mr. Deepak from Nepal is asking. I hope Vada-san is following the question, right? Mr. Vada.
Yes. Can you hear me?
Okay. Yes, now I can hear you. Yes. Yeah, so the question is, Mr. Deepak is asking from Nepal. Hi, very relevant for Nepal case as well for landslide early warning systems. My question is, what determines the lead time for early warning, landslide early warning systems, and what would be the maximum lead time in general?
Okay. in my project, we interview with the local person and the local officers, and then we collect the information how much time, how long time is necessary to distribute the information to the grassroots level. As a result, we conclude that we need 2 to 4 hours lead time is necessary for in Sri Lankan situation. So we should consider about that situation. Yes.
Yeah, and that lead time depends on the time and then the other characteristics as well, right? Like it kind of a general average scenario, I think, which you are
Yes.
referring to. Yeah, so your study is very interesting, and there is another question. It's Tushar Pradhan is asking, SWI, that index is quite interesting. Had it been implemented in Japan in real time, is it used by the Japanese government for issuing early warnings?
Yes, that's you are correct. The soil water index is utilized in Japan, and Japanese meteorological agency calculates the soil water index by using real-time radar rainfall, and they distribute the risk map of the real-time soil water index data.
Oh, okay. That is real time, huh? Like it updates with the rainfall and all the other characteristics.
Yes.
Like is it how I'm in the NRO for a couple of years or months. Yeah. So what is your experience? What do you think? Can it be possible us to in Sri Lanka to implement these kind of early warning, real time early warning system? But because your like basis is really valid, because we can't say just 100 meters or 75 millimeters or 150 millimeters as the threshold. It should be there are other characteristics which we need to consider. Which are like something like SWI. So how feasible is this in Sri Lanka?
Sorry, I can't hear you completely. Hello.
Dr. Shiromani, did you hear me?
Yeah, I can hear you.
Sorry.
Okay. So Mr. Vada, my question is, like, I mean, how feasible to apply this the SWI real-time monitoring system, issuing early warning systems in Sri Lankan context, like let's say NBRO is implementing, how feasible that is technically, and then all the other infrastructure.
Yes. NBRO is installing many automatic rainfall gauging stations in the mountainous area. So I believe that they can use that instruments and the soil water index to improve the early warnings in Sri Lanka. However, the most big challenge is the accumulation of the past data, landslide records, and rainfalls. It is a key factor to improve the accuracy of warning, I think.
Thank you very much, Mr. Vada. Dr. Shiromani, do you have any other questions?
No, thank you very much, Mr. Vada.
Thank you.
So, shall I move to the next presenter?
Of course, yes.
Yes. And our next presenter is Dr. Raza from Philippine School of Business Administration. He's going to present about understanding alteration to surface cover in developing urban heat island, enhancing city climate change adaptation capacity, Quezon City, Philippines. Over to you, Mr. Raza.
Okay, thank you very much for giving me a chance. What I will do, I will share my presentation already recorded. Okay.
Yeah.
I will share my recorded presentation. This one, right?
It will. Mr. Roshan, are we going to?
Hello. I think we can play the video from here.
Yes. We'll play the video from here, I think.
Dr. Rasa, I think we can't hear you.
Where is the here?
So we cannot hear the voice.
Hello.
Just a moment. Just a moment. Just a moment. Let you hear. There is an option here to say with voice. 1 second, please.
Dr. Rasa, shall we try from this end?
Yes,
I
yes.
think,
Okay.
I think it's better, no? Like we will try from
we
this
can try
end.
to
Okay.
do the recording from
Audio setting.
yes, please.
Roshan, please start the video.
Good afternoon. I'm Tabassum Raza. The title of my presentation is Understanding Alteration to Surface Cover in Developing Urban Heat Island, Enhancing City Climate Change Adaptation Capacity, Quezon City, Philippines. Statement of the problem. Cities are on their fastest pace toward urbanization. For example, Quezon City in the Philippines is developing aggressively, and the effect of urbanization, that is, the replacement of vegetation by building structure, is changing the microclimate, raising summer temperature by up to 7 degrees Celsius. Actually, this research is a significant feature of a study on urban landscape sustainability work that I have done in 2017. Two major urban impacts have been identified. Urbanization affects climate. Cities tend to be hotter than surrounding countryside and create what is known as urban heat island. Photo on the left depicts comparison between rural and urban areas. And photo on the right is the real-time urbanization in one of the areas in the Philippines. Number two, urbanization affects hydrology. Cities shed more water as runoff into their streams and rivers, causing periodic flooding. The photo on the left shows rainfall percentage in terms of flooding or runoff, and the photo on the right shows water polluted with solid waste due to unplanned growth of the cities. To resolve the said problem, this study seeks to achieve the following objective. Number one, to characterize urban environment that includes determining the evapotranspiring area, surface temperature, and surface runoff. Number two, to develop an action plan. Determining the evapotranspiring area comprises of two phases. Phase one, urban morphology type identification. Google Earth 2015 satellite image of Barangay Greater Lagro is superimposed on the Quezon City land use map for its surface cover analysis. You must be wondering, what is barangay? Barangay is the smallest political unit in the Philippines. So for Quezon City, barangay is the smallest political unit of Quezon City. Urban morphology type identification. So you have seen in previous slide the satellite image of Barangay Greater Lagro. So using the satellite image, we developed the real-time land use map or morphology type identification map using the GIS. For this study, the Barangay Greater Lagro urban morphology type is identified as R1 low density residential zone, R2 medium density residential zone, and so on. You can see the legend on the extreme lower right part of the map. Now, phase two is about the proportion surface cover type in percentage. The proportion surface cover types, that is urban morphology types by sub areas. In the previous map, you have seen that we have designated some of the area by letters A, B, C, or AB. So it means low density and high density. So here, these are the logs. You can read at the bottom or the lower part of each log, specifying each zone's proportional surface cover type in percentage. Area low density, A, Lagro Southeast. If you see predominantly, you can see it is predominantly high density residential, low density residential area. Now look in this log, which is area high density B, Lagro East. So we have now proportional surface cover type by percentage. This is for each zone. Now on the next slide, you can see the overall Barangay Greater Lagro surface cover analysis. So this surface cover analysis depict that the 84% of Barangay Greater Lagro is currently an impervious area. 7% is bare soil and around 9% is evapotranspiring. Phase 2 also comprises of residential green segregation. So the residential green area segregation is done to know the green in other desired UMTs in the area. I mean, urban morphology types in the area. This information is usually used to measure the differentiate impervious and evapotranspiring areas. So these measures are used to determine surface temperature and surface runoff to provide climate change adaptation options in the local climate change action plans. Estimation of evapotranspiring area. In the case of Barangay Greater Lagro, around 9% of the total area is composed of evapotranspiring. Furthermore, in the case of highly developed scenario, this proportion will decrease to minimal. This information is also required to determine the surface temperature and surface runoff of the area under study. So how we will estimate those areas? Determining surface temperature and surface runoff. The STAR tool can be used at a neighborhood scale to assess the impact on surface temperature and surface runoff of different land cover scenarios. So as you have seen that previously, we have phase 1, phase 2, we were trying to know the surface cover. Basically, that is our land cover scenario, which we will be using into the STAR tool. STAR tool is a step-by-step procedure in determining surface temperature and surface runoff. For example, step 1 for surface temperature, the first step is to designate the area, what area of study. So you can see in this diagram, there is a Barangay Greater Rizal. And here, this is for the temperature, surface temperature tool, the surface runoff tool. Second step is we have to provide the surface cover scenario. In surface cover scenario, the surface cover is in different topologies. So for example, buildings, major roads, other impervious surface. So we have already identified these in our previous section. Same land cover scenario we will use for the surface runoff. In the temperature, we will look the mean temperature during the summer, most half, and what we are expecting during 2050s. Here in this part of the runoff, we will look into the rainfall, the maximum rainfall expected in the year, and then in the future, 250. So once we run the program, our program show us that there is a temperature which we will be expecting in 2050s if the system will be keep on developing as it is developing. Here, the surface runoff is given here in this tool is at 8 millimeter precipitation, 70% of the runoff we are expecting. It means if 8 millimeter rain will fall, 70% of that rainfall will become a surface runoff due to the reason that there is a more build-up area or cemented area than the grass or pervious areas. So the conclusion is that the surface cover analysis output revealed 84% of the Barangay Lagro is currently impervious, 7% is bare soil, and 9% is evapotranspiring. So now surface temperature, that is the calculation of a surface temperature. And this one is a surface runoff, which is for 8 meter, it is 79%. For 100 millimeter rainfall, it's 98%. It means that once there is a rainfall 100 millimeter, 98% will be coming runoff. So this is our action plan 2020-2030. There are program projects, activities, department units responsible, time frame. There are around 12, and that is it. Thank you very much. And you can see these one action plans again, and you can borrow this presentation and read them all. These are the areas which need to be corrected in terms of fixing our studies desired goals. Thank you very much once again, and have a very good day.
Thank you very much, Dr. Raza, for very interesting presentation. So I just, I cannot see any questions in the chat box yet. So I just wanted to know, in Philippines, do you experience heat waves?
Yes, indeed, we encounter heat waves during our summertime.
Okay, so how do you think that in future we can expect more and more heat waves? So how this will affect the urban heat island effects, as well as extreme rainfall events will lead to more and more flooding and this kind of hazardous events?
This study which we have done, basically that study's main objective is to see how anthropogenic activities they contribute, excuse me, how the anthropogenic activities contribute in the normal projections of climate change. For example, in the normal projection of climate change, it's the current temperature in a very hot summer day is let's say 28 during nowadays. Then what will be the projection in 2030s and 2050s? Let's say in our case in 2050s, we are expecting that the temperature will be around 31, which is more than 2 or 3 degrees more than current situation. But that one prediction is based on the climate change scenario, right? Now what about the anthropogenic activities, which mean we are developing haphazardly, we are keep on covering all the pervious blanket or pervious soil into the sealing it with the cement. So what will happen? We will be decreasing the number one, percolation of water, and number two, we will be absorbing more heat from the sun. So it works both ways. It will increase the temperature of the nearby areas. So my temperature in a certain area, urbanized area, will be higher than the temperature from the little far from that area. It is due to the reason that the area which is in the middle of the development, it is more cemented, it's more sealed. So when heat waves come, that is already, it's just like when we project our projections, how it will impact the temperature in the future. It is exactly the same logic that if we are expecting a heat waves in future, if the temperature, let's say our heat wave, let's say in India, in Pakistan, in Sri Lanka, the heat waves are really hot. It's maybe 40 degrees centigrade or up. But if you go to the England, for them 24 to 26 degrees centigrade is already considered heat wave. So is here in the Philippines. For us, 30 plus temperature is already hot, considered hot. So what if there is another sealing of the cement or development, which can cause another 3 to 4 degrees centigrade addition into the 35, then it will reach to 40. So there is a very big change in the temperature, just reducing the greenery and putting the ceiling. And it affects similarly with the runoff.
Yes, thank you very much for your explanation. And I want to know, so what percentage you recommend to increase the green cover?
Okay, if you increase 10% of green, you expect 3 degrees of temperature to be reduced. Okay. That is how it works because you have to understand the START tools, we borrow it from Britain. So it was prepared for the atmosphere in the in the Britain, let's say Manchester and Leeds, they have different temperature. Like 32 is already quite high temperature in that area. So if we increase 10% of vegetation, we can go around 3 to 3%, 3.3 temperature decrease, and that works there. However, at the moment, I am also trying to consult with the person who developed this tool, that how some parameters can be maybe customized in a Philippine context. I have used it already. It works, and I show you that there are readings I can get it.
Okay, thank you. We have a few questions in the chat box. One from Mr. Tushar Pradhan. He asked, have you considered the sea level rise and soil water level in your study? What structural and non-structural measures you intend to combat the results?
Let me read it.
Mr. Tushar. And another we have from Mexico City also.
Okay. I will go. I can read it. That is Pauli. That is Pardhan. Pardhan say, have you considered the sea level rise and soil water level in your study? Actually, Pardhan, it's like this. When you say sea level rise, that and the other studies, they are already included in the climate change model. Okay. That is part of the climate change model. When we consider the climate change model, we apply it. That is where the model run and give us 2020 and then 2050 scenario. But here, what I'm doing is I'm considering now the temperature of the surface. How much temperature of the surface will increase? What are the factors to consider? The cement. Why? Because of the theory that in the rural area, when the sun strikes to the soil, less heat will trap. But in the area which are highly urbanized and cemented and sealed, more heat will be trapped. The same is true with when it rains or if there is a precipitation in the rural area, the soil is very much porous. It means that there is enough space between the soil particles, and the void spaces can be filled up with water, and then it can absorb some of the water. And if there is a, let's say, 10 millimeter rain, 10 millimeter rain mean in the rural area is maybe 2% runoff. However, the same millimeter rain in the urban areas mean there is no absorption. Most of the water will run on the cement unless there is a proper drainage and others. That's why this model is really for the urban and the rural areas, how to bring the urban areas into urban gardening, how to bring the urban area to be suitable or adaptive to the situation. So in this case, adaptation is different from mitigation. In climate change, adaptation is we adapt. In climate change, mitigation is long-term and slow setting phenomena. That's where sea level rise come in. But when we are dealing more on adaptation. So in adaptation, we consider those factors which are directly related to the situation. I hope so I answer your question.
Okay, thank you, Dr. Raza. There's another comment from Mexico City, Paulino Alonso. So he said that they have the same problem with urbanization and temperature rise. They are considered to preserve lakes, green zones, building to decrease temperature.
Yes, I totally agree with that. If you look at evapotranspiring is consists of water bodies, grass, greens, you join them. The totality of evapotranspiring is the area which have water lakes and lagoons or rivers. That is one of the adaptation measures. And the other green zone buildings mean in my action plan, I have asked that we have a Quezon City green building code. So this green building code can be implemented where we also give the certificate of recognition to the commercial building who follow all the green buildings codes. For example, roof gardening, treatment of the water, having some lakes or some falls, so which can relatively cool down the temperature near the building rather than the other areas. So that is a very good example. That's how the buildings can decrease the temperature, by providing greenery around the buildings. There are many examples for urban gardening in these days available. So I totally agree with Mr. Paulino that this is really a good approach.
Thank you. We have another question from Achidi De Silva from Sri Lanka. So we need quick answer from you because we are running out of the time. Thank you very much for timely important research. I want to know what mitigation measures you are proposing, and especially for cities and for policymakers.
Okay, when you say mitigations, we have to look into two things. So one is carbon footprinting. Okay, so for carbon footprinting, we need to decrease our fossil fuel use. We look for the alternative energies. And the second one is when you say coastal cities, which are the sea level rise, that is impact the coastal cities. Just like Manila city is a coastal city. Bangkok, Thailand, Bangkok is a coastal city. So these cities are prone to, or Maldives has a coastal cities. So those islands which are along the sea, they are exposed to a slow pace phenomena, climate change phenomena. For that, we need mitigation. What can be the best mitigation? You just elevate your houses near the sea level, near the coastline. So as the sea level will rise, the houses which are near the shore has to go a little bit away. So there is one of that kind of. And then the other one is use alternative energies. Just use LED bulbs. So you will not spend too much fossil fuel to warm the environment, and finally it will add into global warming, and that will add into more conventional negative currents in the sea, and then that rise to the typhoons and extreme weathers and so on and so on. So there are domino effects on that. That's what I say. And there was another question for if the concrete really increase the temperature. Yes, indeed, if you put too much cement, it will increase the temperature. On a hot day, the cement will absorb the heat, and in the evening it releases the heat. So the area nearby will be hot. So you can experience it going to an urban area and live there, and living in a rural area, you can feel the temperature has a 5 to 7 degrees difference between two situations. Sorry for long discussion. So I hope I have answered the question. I would like to say sorry for my one slide in Start Tool where I used the word Barangay Rizal. Because I work for Barangay Rizal, actually this is Barangay Greater Lagro. Okay, so please apologize me for that.
Thank you very much, Dr. Risa, for excellent explanations. Now I would request Dr. Chandana for the next presentation.
Sure, and thank you very much, Dr. Rasa, for the and all the participants for the very interactive discussion. This discussion is very valuable for everyone, I guess. So we will be moving into the.
Dr. Chandana, sorry for 1 minute. I just would like to acknowledge the presence of my class. I invited them because some are taking their MBA in disaster risk management, and some are my planning student. So thank you very much for the management to allowing my students to have this opportunity to attend your this very well esteemed conference. And I would like to thank you once again for a very constructive participation among other participants.
We are very much pleased to hear that, Dr. Esa, and we are really happy about it. Thank you very much. So we will be moving into our next presenter. The presentation title is Synoptic Analysis for the Disastrous Heavy Rainfall in May 2016 caused due to a low pressure system. The first author is the Varnasurya A, and from Department of Meteorology, Sri Lanka, and most of the authors are from Department of Meteorology and then Association of Disaster Risk Management Professionals of Sri Lanka. So when you are ready, you can start the presentation.
Good evening, ladies and gentlemen. I am going to present a case study about synoptic and mesospatial background of the disastrous heavy rainfall in Sri Lanka caused by a low pressure system. I am Anusha Varnasurya, and along with my group, Mr. K.H.S.M. Premalal, A.W.H. Kumara, and Chatuska Premalanda did that case study. Outline of my presentation, I would like to briefly discuss about introduction and also objective and data and methodology, and discuss results and findings, and also conclude. Uh, a tornado cyclone in Bay of Bengal caused massive damage to human lives and economy of Sri Lanka, with flooding and landslide in the western part of Sri Lanka during the third week of May 2016, although it did not make a landfall in Sri Lanka. But it made a big damage to Sri Lanka. Estimated total financial damage was around 250 to 280 billion rupees, and nearly 200 casualties were reported, and 619 houses fully destroyed, and 472,000 families were affected due to floods and landslide. On the left-hand side corner, that map shows the daily rainfall distribution on 15 May 2016. And you can see there was a 373 millimeter rainfall in the northern part of Sri Lanka, and western part of Sri Lanka, 263 millimeter rainfall. But interestingly, there is a river we call the Kalni River. Along the river and also catchment of that river reported very heavy rainfall, more than 200 millimeter rainfall. That extreme rainfall caused the flood situation in the western part of the country, because that flood stagnated 3 to 4 days in that same area. So the flood situation is enhanced. And also that right hand side images shows the how flood is in the Colombo area, and landslide, the massive landslide reported in the western slope of the Central Hills. Objective of this study, identify and document the possible synoptic and environmental characteristics of the heavy rainfall events on the 15 May 2016 over western and other part of Sri Lanka with associated with that system. And which data we use? We use the JRF55 and encephalitis data to identify the large-scale atmospheric pattern associated with the system. And also interactive tool and list of climate system that we call the iText software we use to analyze the data. And also rainfall analysis was done by using ArcGIS, and that's also used to analyze the horizontal and vertical profile of the atmosphere. And this is the our results. This upper panel shows the daily average sea level pressure distribution from 13 to 16 to May 2016. You can see on 13th and 14th there is no close isobars, but there is some indication about the disturbed situation. But on 15 there is a 2 close isobars, and on 16 it concentrated into the eastern part of Sri Lanka. We can assume that the 15th the disturbance developed into a low pressure system, and subsequently on 16 it developed into a depression. And lower panel shows the hourly pressure distribution at meteorological station in the northern part of the country. The green color is the lowest pressure recorded at Trincomalee area. And that Trincomalee is the coastal station in the northeastern part of the country. That means we can just assume that system is moved along the coast, not came into the country. This is the daily average surface pressure distribution with surface wind pattern, and also upper level and middle level wind pattern. The left hand side figure shows the daily average surface pressure distribution with surface wind pattern on 15 May. The color depicts the isobars. You can see the low pressure system in the our Sri Lankan vicinity, and also the winds, the high pressures in the Arabian Sea as well as the Bay of Bengal. But you can see the winds come from the Arabian Sea and converge to the west part of Sri Lanka And also, the winds come from the Bay of Bengal, converge to the north part of Sri Lanka. When we move on to the right-hand side panel, upper panel, it shows the 500 millibar wind pattern. It clearly shows the cyclonic circulation over Sri Lankan region. That means that the circulation, it's developed up to the middle level from surface. And also the upper level 200 millibar wind pattern, it shows the divergent pattern over the Sri Lankan region. That enhance the cloud development. Then we analyze the low level relative velocity as well as the pressure vertical velocity. Left hand panel shows the low level relative velocity. You can see positive relative velocity can be seen over the Sri Lankan region. And the right hand side shows the pressure vertical velocity. It shows the negative pressure vertical velocity. That means very favorable condition for vertical development of the clouds. And also next we analyze the divergence over low level and the upper level. The low level, there is a negative divergence, that means positive convergence. And upper level, the right hand panel shows the upper level divergence, positive divergence. That means that it's also very favorable condition for the developer. And next we consider the dew point depression. The left hand side shows the average vertical profile of dew point depression. We average 7 to 10 within the 7 to 10 latitude area. It shows that you can see within the black circle the very humid, the very high moisture content. You can see there is like a moisture river, and it's a moisture river comes from the Bay of Bengal to the Sri Lanka, and also the from Arabian Sea to Sri Lanka. It's also but there is some middle level drier condition is around 700 to 600, little bit drier condition over because 80 is the Sri Lankan longitude. You can see that vertical profile of the dew point depression. And right hand panel shows the low level dew point depression. It shows the leading tongue of high moisture extending from southeast Bay of Bengal to the Sri Lankan region. And next, this is the satellite images. You can see the cloud development, the dense cloud development from southeast of Sri Lanka to the gradually northern part of Sri Lanka during the 15th May 2016. And also the Madden Julian oscillation, which is very significantly affected Sri Lankan weather when it comes to the Indian Ocean. On 15th May, during the month of May, this is the this is in green color depicts the month of the path of the MJO during the month of May. You can see magnitude is very high, greater than 1, and on 15th May it was in the middle of the phase 2 and 3. That means it was in the our region. This is also very favorable for development of convective activity. With that, all the available, we analyze the data, we can conclude the cyclonic circulation persisted at the mean sea level just to east of Sri Lanka and adjoining southeast Bay of Bengal. Because the system actually the Ronu cyclone developed at the beginning, it was the disturbance, like a low level atmospheric disturbance on 13th, but it developed in the 15th. It was just a low pressure system. With that heavy rainfall caused by that low pressure system. That's the interesting feature. The low level wind field indicated that there was an eastern northeasterly flow from Bay of Bengal towards the northern part of Sri Lanka and western northwesterly flow from Arabian Sea towards the western part of Sri Lanka, which converge over north and west region of Sri Lanka. The low level easterly flow and westerly flow helped to transport high amount of moisture from Bay of Bengal towards the northern and from Arabian Sea towards the western region of Sri Lanka. An orographic effect also triggered to enhance the rainfall of western slope of the central list, which caused the massive landslide. The strong low-level convergence helped to carry moisture up to 700 to 500 levels, and accordingly, high relative humidity extended up to the mid-tropospheric level. However, mid-level drier condition, little bit drier condition was, we can see the drier condition. This is also some kind of triggering factor. The high level relative vorticity and low level convergence and upper level divergence, a favorable pressure vertical velocity of Sri Lanka preceded that development of heavy rainfall on 15th May 2016. And not only that, presence of MJO in phase 2 and 3 with higher amplitude was another favorable factor for the enhancement of that activity. With that, but actually, we need further study is required to understand more about such cases, and also high resolution analysis is needed to identify the localized effect. With that, I will conclude my presentation. Thank you very much for listening.
Thank you very much, Ms. Anusha. So the floor is open for questions, and then in the chat we have a couple of questions. And first one is, I will take this Mr. Sri Janaranjana Ekanayaka's question. Is that low air pressure from because of the positive wind stress curl during May?
Yeah, actually, during the May is the nearly the normally onset of southwest monsoon will happen in the end of May, but this is the mid of May. Normally, wind flow is not much stronger. Southwesterly flow is not much stronger in that period. Mostly the wind speed is not much strong, but there may be a positive wind stress during that situation.
So with that, I thought of connecting this question what are the impacts of same type of weather system developed in Bay of Bengal during the season such as second intermonsoon and the northeast monsoon season on extreme rainfall events? So
Yeah.
like I think you have studied in pre-monsoon season, isn't it?
Yes. Yeah. Actually, it's completely different because during the southwest monsoon period, the monsoon flow, large scale monsoon flow, cross equatorial flow comes from the mascarene high. But in northeast monsoon period, that large scale feature originate from the Siberian high. That means the easterly monsoon flow. So if there are any system developed in the Bay of Bengal during the northeast monsoon, sometimes if that not develop up to the cyclone as a low pressure system or depression, if it come towards the Sri Lanka, the rainfall will be enhanced. But if its system develop in the cyclone, the rainfall will be suppressed and more drier condition can be seen over the northeast monsoon as well as in the south intermonsoon, because intermonsoon season also the system is come towards the Sri Lanka is okay, rainfall will be enhanced, but the system is developed into the cyclone, the more drier condition, the drier wind flow coming over the Indian landmass, this will be direct to the drier condition.
That makes sense. Thank you very much, Ms. Anusha. There's another question. So it's DMCU Colombo asking this question. Thank you very much for a nice presentation. What are new methods and equipment in order? That's what the question says. Do you have any answer for that, Ms. Anusha?
Is that question methods for what new methodology or new instruments to forecast this type of question?
So. Maybe, yeah. We will structure it that way.
Okay. I think actually, especially Sri Lanka is in the tropical region and is close to the equator. This is very challenging task for the identifying the heavy rainfall localized event, and especially in our mountains area, this is also another triggering factor for the heavy rainfall event and localized. This is actually we need this type of studies. Further, actually, I think instrument also alone only instrument can't do that. I think we have to develop the numerical weather prediction and fine tune the and I think this type of especially numerical weather prediction should be improved with that verification with the observation data and this type of studies. So I think we will expect to develop with that situation.
Very, I think I completely agree, 100% agree with what you said. Like, instruments alone can't do much, but like the scenario analysis and this further studies on previous information data. That is what we need. Like, and then like that is very important to understand the situation. Is there any other questions? And thank you. I mean, it's a really valuable presentation and really valuable research. If there's no other questions, Ms. Anusha, I would like to thank, and please continue this kind of research and data analysis, so then it will enhance the I think the knowledge base of the practitioners. Thank you very much.
Thank you.
Okay. Yeah, thank you,
Yes,
Dr.
Dr.
Chandana. Now I would like to invite Mrs. Dr. A.D. Silva from Sabaragama University, Sri Lanka, to present about local responsiveness to climate change in climate, a case of underutilized marine and aquatic resources. Mrs. D. Silva, over to you.
On behalf of our research team, I would like to welcome all of you for our research presentation. Our topic is local responsiveness to changes in climate, a case of underutilized marine and aquatic resources. I am Janaranjana Eknayaka from Sabaragama University. This is our outline. At the beginning, I would like to give you some introduction about how our research topic linked to today's theme. Actually, when considered about the climate change, it derives, we know, some severe and adverse weather conditions such as heavy drought condition and heavy rainfall conditions. According to these impacts, the world food production getting low by low, day by day. Because of that, the hunger crisis of the world is getting increased. And the World Bank Development Report in 2010, here you can see the figure. According to this map, they predicting during 2050 how the food insecurity level affects for the world. Actually, what is this food insecurity? When the people cannot fulfill their safe and nutritional food requirement, then the state would be this food insecurity level. And according to this map, you can see our small country also will get some huge impact from this food insecurity state, and we have to prepare for that. This is the important thing. And before we prepare, we need to know what is our present situation. This is our present situation according to the World Food Program. It is very colorful map, but we can't get some happy about that, because these colored areas represent the vulnerable areas for the food insecurity context. And when consider about this map, you can see some most of the rural areas of the Sri Lanka covered with these colored patches. And the important thing is we want to mention we cannot be like that, because we know as an island and also a very resourceful country, we have good soil and we have good freshwater system, and also we have a good sea. So if we can manage our resources well, then we can mitigate this situation and we can overcome these challenges. This is our view. Actually, when consider about the fisheries sector, because you know, as an island nation, we have good opportunities from the fisheries sector. That's why we are focused on this fisheries sector. The current situation is currently we are getting 70% of protein requirement from this fisheries sector. And also there are two subsectors, you know, in the fisheries sector as marine and inland. 86% of food product, fish products comes from the marine sector, and the 14% of the fish product comes from the inland sector. The important thing is most of these marine sector based on the target fish fishery. It means tuna-like species they are catching always. And when consider about the inland sector also same, they are focused on the stocked carp and tilapia species. So the tragedy is, although we have a good fishery resources, currently we are importing our excess demand from the other countries. It is not good thing, because if we can manage our fisheries resources very well, we don't need to import them from the other country. When consider about the marine sector, as I already mentioned, most of our fishers based on the target fishery, like tuna species, and they ignore the other undervalued species. It means underappreciated and underutilized species. So most of these highly valued species currently reach to their and exceed their maximum sustainable yield level. It means MSY exceed according to the reports. And when considered about the inland, every time we have to stock these target fish. But if we can shift towards the underutilized fish, then our fisheries sector would be more strengthened according to our point of view. And what are these underutilized fish species? Actually, when fish species has some underappreciated character, then the consumer preference will be low, and subsequently the market value also getting low. Therefore, fishers don't like to catch these fishes, and sometimes they catch these underutilized fish as bycatch. Although they catch these underutilized fish, they sometimes throw away to sea, or sometimes they sell them as for cheap market. Then these underutilized fish become trash fish. In our view is we need to make this trash into cash. This is our theme, because if we can make money from this trash fish, and if we can give high value for this underutilized fish, our fishery sector will be strengthened, and also we can feed our people with this challenging climate change event. This is very important, and therefore our objective is give an insightful discussion about how to enhance in the local underutilized fishery as a strategic local response for the global climate change crisis. And this is our methodology. We collected marine fishery data from the marine fish landing sites, 9 marine fish landing sites, and for the inland sector we collected from 5 inland fish landing sites. For the marine sector, we collected data from fisheries inspectors, and for the inland, we collected data from extension officers of NAGDA. The data collection methods were field surveys, in-depth interview, focus group discussion. From these data, firstly, we identified suitable underutilized species, and then rapid market analysis for them, and at the end, we analyzed the underutilized fishery value chain. Now I am moving to our results and discussion part. Here you can see this is the marine underutilized food species identification. According to this map, you can see we have identified 13 marine underutilized food fish species, and these are the images of them and how they distribute around Sri Lanka according to our data. And these are their local name and also the scientific name as well. Especially Savalaya, Silava, Madua, Katta, these are the local names. Most of the time we could find. And here you can see the catch composition of the marine landing sites according to these underutilized fish species. According to these data, especially as I already mentioned, Katta, Madua, and Sivia, Potubari like species is very important, and they have very high potential to give some high catch for the fishers. So if we can manage this marine sector, then our people not be hungry in future, especially during 2015, as I mentioned in the beginning. And this is the inland underutilized food species we have identified. We have identified 16 species, and these are the images and their distribution, how it is happened. And especially here you can see Veusalea. Veusalea is most important species we have identified, because even local regional villages and other fishers also told us that Veusalea has a high potential to become very good, give some good harvest for the fishers if we can manage this fishery. And that's why we need to emphasize, and we need to explore some other post harvest mechanisms and also some other value additions and innovative practices for this fishery. It is very important. And the other important thing when consider about this inland underutilized food fish species, most of them have high survivability during harsh conditions, such as rough conditions. So they can use for this climate change challenge. It is very important. And this is how these inland underutilized fishes composition vary along with these landing sites. Here you can see Vausala is very common every fish landing sites, except in the Udawalawa, and these are other species how vary with this landing site. And now I am going to talk about underutilized fish value chain. Here you can see this value chain is not much complex. The upper stream is composed with the small scale fishers, it means suppliers, and the midstream composed with the processors, especially dried, salted fish and moldy fish processors, and this lower stream composed with the consumers and retailers. According to our impact of entry barrier on different fish landing sites, you can see here the legislation work is very much tough in the marine sector, considerable when considered about the inland sector. And the other important thing is in both sectors, you can see boats and fishing equipment requirements is very high. So we have to give some subsidies for them to buy them, these equipments and boats. And also it is very important to show you this storing facilities not in a acceptable stage in our country. Here you can see, because if we trying to give some good innovative and value-added products, we need good storing facility and also transport facility. To develop these strategies, we need to give aware for these fishers, and it means knowledge dissemination is very important. It also we identified, and this is the value chain upgrading factors on underutilized fishery in Sri Lanka. Here you can see, especially I need to emphasize this hygienic food and safety practices and newest technology usage and value-added products is very low. So we have to develop this sector. Unless we can't achieve this underutilized fishery getting increase. This is very important, and these are our conclusion. There are 13 of potential marine underutilized fish species and 16 of inland value underutilized fish species we have identified. Both value chains were operated regionally in season, and nature of the chains were short, fragile, and less complex. And the other thing is underutilized fishery resources were recognized as a promising answers to mitigating the threat of dependency on a few commercial species, as I already mentioned, tuna and carp species and tilapia species, fish species, while able to feed the local people in the disaster lockdowns. And finally, application of local knowledge on post-harvest management and value addition opens up new avenues to the actors of fishery value chain. These are our acknowledgements and these are our references. Thank you very much. Additionally, we have here added our suggested strategic interventions for the value chain nodes and their issues. Thank you very much.
Thank you, Mr. Ekanayaka, for giving us a presentation on a very important topic, especially how we can promote the underutilized fishery in Sri Lanka, which is very good adaptative measure. And have you done any research on the nutrition level of these underutilized fisheries, fish in Sri Lanka?
Actually, madam, in this research, we based on the value chain analysis. For that, we didn't do these kind of analysis, but it is important actually.
Yeah, especially to promote that.
Yes, of course, ma'am.
Yeah. And any other questions? I cannot see any questions in the chat box. And thank you very much raising this important issue and giving us some sort of like issues we can face in future to when we promote this type of underutilized fishing and aqua resources. So thank you very much. And as we don't have much time, shall we move for the next presenter, Dr. Chandana?
Yes, Dr. Shivamani, give me 1 second. Yeah, so our next presenter is like now we are moving into the Himalayas, saving lives and livelihood of the mountain communities through glacial lake outburst floods, risk reduction and early warning systems initiative, a case study of Imaja Glacial Lake in the Everest region, Nepal, Himalayas. The presenter is Mr. Deepak Casey. Mr. Deepak, whenever you are ready, we can start the presentation.
Every year, climbers travel to the Himalayan mountains in hopes of celebrating at the top of the world. Sometimes referred to as our planet's third pole, this region holds some of the world's most iconic and challenging terrain. However, this landscape is changing. Many of the glaciers on popular trekking routes have retreated and given rise to new and larger glacial lakes, which typically form when glacial meltwater is blocked by ice dams or glacial sediment. And worldwide, retreating glaciers have led to an increase in the number and size of these glacial lakes. Researchers supported by NASA's High Mountain Asia program use new supercomputing abilities and hundreds of thousands of Landsat satellite images to catalog and analyze 3 decades worth of glacial lake boundaries in the first ever global study of its kind. The study found that, during that period, global glacial lake volume increased 48%. The analysis concluded that, worldwide, smaller glacial lakes were growing at a more rapid pace, and that lakes were occurring at higher elevations than previously documented. This new assessment is a critical component to understanding how these growing lakes may impact tourism, elevate hazard risk, and affect infrastructure for the communities living downstream, and bring us one step closer to understanding the global changes to our cryosphere.
Good morning, good afternoon, and good evening. This is Deepak Casey. This is my pleasure to be a part of this international symposium from Nepal. Nepal is the country of mountains, including the Mount Everest, the highest mountain in the world. Nepal is fortunate to have such mountains. It's one of the 8 countries of Hindu Kush Himalaya region, located in between 2 economic giants and also the biggest greenhouse gas emitters, India and China. As a practitioner working in the field of climate change adaptation and DRR, today I'm sharing a case study of a successful intervention on climate change adaptation in the highest altitude in the world, located in the Everest. I will be covering Nepal's vulnerability in the face of climate change, particularly on impacts on glaciers and glacial lakes. I'll take an example of one successful interventions on climate change adaptation and DRR by the government of Nepal, UNDP, and with the financial support of Global Environment Facility, GEF, in the Himalayas in the Everest region. I'll present some of the lessons learned and conclusions at the end of my presentation. Nepal is a multi-hazard prone country, particularly that of climate change induced and some geological hazards. Though Nepal is a small country, it has high altitudinal variation with very steep slope landscape to the flat plain, which are prone of multiple hazards. The existing hazards have been aggravated by the impacts of climate change in the recent years. If we look at the temperature things, an annual increment of maximum temperature in Nepal is like 0.056 degrees Celsius. And however, warming rate is greater in the mountains. Even if we limit the warming rate to 1.5 degrees Celsius, as per the Paris Agreement, the warming of in the mountain will be even higher, around like 0.03 degrees Celsius, posing the higher threat of glacier meltings in the region. A changing climate can result in unprecedented extremes and has multi-sectoral impacts, particularly on lives and livelihoods of the people. Hydromet disaster alone accounts for loss of 333 lives and the property worth over US $17.24 million each year due to the extreme climate events. The biggest and the most visible indicator of climate change is the accelerated glaciers retreat and expansion of glacier lakes, which potentially results into globs. Recent publication in Nature Science also highlights the increment of global glacier lakes in volume, numbers, and areas. This holds true in Nepal's case, and areas of glacier lakes have been increased in Kosi, Gandaki, and Karnali basins, which are the three major basins in Nepal. The increased number, areas, and then the volume are correlated quite well with the decrease of glaciated areas. The example could be Trakaring glaciers, which is located in the in Nepal, eastern in Kosi Basin itself. And Chorulpa is one of the biggest glacier lake of Nepal, is in this glaciers. And also Imza glaciers, which leads to the Imza glacier lake that we are talking about. And to note, these two glacier lakes were ranked number 1 and 2 as a potentially dangerous glacier lakes in Nepal. Nepal has already witnessed 26 glacier lake outburst floods and faced huge loss of lives and properties in the downstream, in we can say in $1 million figures. And to note, almost half of the total glacier lake outburst floods were originated from Tibet region of China. The concentration of glacier lake outburst flood case was in the Koshi Basin, and to note, at present, the highest number of glacier, potentially dangerous glacier lakes are also in the same region. And the settlements, roads, bridges, hydropower projects, and other infrastructures built along the river valleys have a greater risks with glacier lake outburst floods in Nepal. I can give you an example. This is an example of devastation. The recent glacier lake outburst flood occurred in the year 2016 in Botikoshi region in the downstream of Tibet autonomous regions, and that has devastated the Botikoshi hydropower and other infrastructures in the downstream. And if you look at the total value at risk under the model glacier lake outburst scenario in one of another glacier lakes in Nepal called Thulagi, has more than more than 400 million US dollar. So it's a huge amount. You know, the risk that the potential risks we can think of. Out of 3,624 glacier lakes of size like reasonably 0.003 to 5 square kilometer, 2,070 are in Nepal, and lakes are larger than 0.02 square kilometer are around 1,410. And out of that, 47 glacier lakes has been identified as potentially dangerous glacier lakes based on the recent UNDP's and EC studies. And these lakes, if you look at the numbers, 21 are in Nepal, 25 are in China, and 1 in India. And these 47 glacier lakes pose threats to downstream in Nepal as well. That's why this is a kind of transbound, risk. And if you look at the glacier, Nepal governments of Nepal's priority, this is one of the priority that has been reflected in different policy documents, including constitutions, NAPA, nationally determined contributions. And if we look at this national DRR policy and strategy action plan that is linked with Sendai framework for DRR, and similarly national planning commissions, which is Nepal's major policy documents, think tank, also linking with SDG for Agenda 2030. They all have prioritized this this REX for that needs immediate actions. And IMSA was one of the, now I'm coming to Lake IMSA, and it was one of the 6 potentially dangerous glacial lakes then, when it was studied back in 2011's ICMO report. And this has grown, the growth has been significant. In 1916, it was a small supraglacial lake, and now if we look at the area, it has more than like 1.228 square kilometers in 2014. The growth can be observed and is significant in the past years. So the priority was given for the intervention, and for lake lowering, a different setup was created with all the studies, science and people's knowledge-based assessments, capacity building of the communities, and the real actions based on those findings. And while we do so, the coordination linkages have been made very in both horizontal and vertical arena, and also it was tried to link that with the government planning process. With this, we followed by detailed field assessments and studies. It took like almost like 3 years. The IMSA Glacier Lake was lowered by 3.4 meters with the engagement of Nepalese army, which reduced the REX of the Glacier Lake outburst flood, and it saves like more than 12,000, almost 13,000 local people, and more than like 70,000 tourists which visit this area, because this area is #1 trekking trail in Nepal. So this is the assessment to these are some of the pictures that we could see of the work that was done, and transportation was done by equipment and materials and Mi-70 helicopters. This is the things that what after the lake lowering, and this is the channels that was done after lake lowering things. Along with lake lowering, hydrometer stations were installed for establishing community-based early warning system to inform the people of potential threats. And this figure shows the illustration of community-based early warning system from upstream to the downstream area with sensors and others other equipments requirements. And this is the alert system that can the people get the assessments. And along with this is also community-based institutions have been established, and they have been trained on the glove REX reductions, first aid, safe evacuation, search and rescue, early warning system, among other for sustained results. This is for, and many media has covered this, international and national. This is also good result knowledge product. And concluding, above 70,000 people have been benefited from this intervention, including the tourists, and every season is the most popular trekking route of Nepal and in the region. Glove reduction needs strong commitments in terms of basically studies, research, investment, and so forth. Lake lowering is costly means, but this is the best way to do so, because reducing the water level, meaning reducing the risks for the downstream. The engagement of Nepal Army was wonderful, because they have that kind of capacity to work in that extreme weather conditions and high altitude area. Otherwise, it would have been climate information is very important, and updates on climate information, knowledge about its changing pattern and possible impact is very important. In fact, research, basically action research is very important, and monitoring and assessment of glaciers and glacier lake and its surroundings should be continued. And regional and international collaboration is the must, because it is a transboundary issue. One country cannot solve the entire problem. And as I mentioned earlier, role of academia and institution is very key, and priority should be action reaches with engagement of local communities. And the mechanism for intergovernmental collaborations and data sharing is important. And if you look at the global commitments like Sendai Framework DRR, Sustainable Development Goals, Agenda 2030, Paris Agreement, these all needs to prioritize such actions for saving the people, lives and livelihoods in the down. With this, thank you very much. Everest region welcomes you. See you in Nepal. Thank you so much. And namaste.
Deepak, thank you very much, and very interesting presentation. And like we time to have a but unfortunately the other session have been started. So I quick ways and then you show most of the enlightening and there you are using and then do you mind explaining?
Dr. Chandan, I couldn't hear you. Could you repeat again if there was any question? I could not see much here.
Dr. Mani, can you hear me?
Yeah, I can hear, but there are some, disturbances. Cannot hear you clearly.
Sorry. My question is like from Mr. Deepak is that have you used any numerical models to predict the future scenarios and then of these flood events and all that?
Yeah, basically UNDP and EC mode has thank you very much for your question first. And then EC mode and UNDP has done Rishi's lake inventories for glacier lakes, and under that study we try to figure out that what are the other glacier lakes that can pose threats to the downstream based on some parameters, but it was not at such a modeling. But yes, there were some elements like the glacier melting rates, the increasing temperatures, so and so forth, but very few limited parameters. So mostly physical parameters like the existing situations were considered, and the lakes were ranked. So that's what the major basis for identifying the lake was.
I thought of asking another question about the interorganizational collaboration, like vertical as well as horizontal, local and national. Like how easy is it to collaborate with different organizations?
This is very interesting. In this particular case, it was also transboundary, and as I said, there are cases where, as I mentioned in my presentation, that more than 15 glacier lake outburst flood were originated from Tibetan region in China. And then in that case, if the data and the current situation of the glacier lakes of that region is not shared for in the downstream countries, then that really doesn't make any sense. And that is one of the example of 2016 Boticosi flood. We didn't know until the flood came and hit us. So something like that. In that context, number one, we need international or transboundary collaborations, and secondly, when we are in a federal situations, and when we have a provinces and local levels, then vertical sort of collaboration is required, because federal decisions and policies has to be translated in the province and local level as well, and they also be supported for making that. In a horizontal line, as you said, there are different partners, there are different multi-sectoral ministries are engaged in such actions, like Ministry of Finance, could be Ministry of Defense or Ministry of Home Affairs, and Science and Technology, and so on and so forth. So this needs a very much like kind of collaborations to get the result, like to cover the entire disaster risk management cycle as a whole.
Thank you very much, Mr. Deepak. Dr. Shiromani, do you have any questions?
No, thank you very much, Dr. Deepak, for excellent presentation. So I think.
Yeah, so Dr. Shiromani, I think, there is a question in the chat box. Yeah. Could you elaborate how the real-time monitoring of glacial elevation done in and how target stakeholders prevent such activity?
Okay, let me take the question. Thank you very much, Tushar Pradhan. In fact, in our cases, the monitoring is it's not like a real-time monitoring, I would say. Rather, we consider the remote sensing and satellite imagery as well. And we, as you know, like we use like this Landsat or Sentinel or some other sources of geospatial tools to monitor the past imageries to look at the changes and glacial lake formation as well as the glacier retreat. And in some cases, like in IMSA that I presented, we have installed automatic weather stations with different parameters that also talks about you know, like snow melt or snowfall and some other parameters in physical parameters. However, at such we don't have much like real-time one, and we are planning now for such a mechanism under Green Climate Fund that we are hoping to get next board. Hopefully UNDP and government of Nepal is proposing that. And it's just as you mentioned, the country, which it's such that there is nothing like a country is helping as such, but as I mentioned, vertical funds like JEF or Green Climate Funds, we do some projects, and that's how we do it. And government also has prioritized those in different policy documents. And as you mentioned also, as how target stakeholders take preventive measures, actions, it's about, you know, to be settled in little like above the risk zone, and do some community-based measures like capacity building training, maybe the evacuation center, evacuation routes to be safer in the area if anything happens. And also, you know, early warning system, as I mentioned, to be mock drills and so forth if that happens. So these are some of the community interventions, and including some of the, you know, river training kind of things, some embankment and so forth. That's what the community and the local people does do for the preventive work.
Thank you very much, Dr. Deepak. I think now we have to wrap up this session.
Sure.
Like we conclude. Dr. Shiromani, any concluding remarks from your end?
Yeah, actually, it's a truly inspiring session. I would like to thank all the presenters for their excellent presentation and sharing their valuable research outputs, which are definitely useful for enhancing early warning as well as adaptive capacity to combat the adverse effects of climate change. And especially, I would like to thank for all the participants for their active participation from different parts of the world, from Mexico to Australia, and so I'm really inspiring actually. Over to you, Dr. Chandana.
Right. Session with me, as you said, like the presenters as well as active participants made this event very active, this session very active. And then since now the other session has been started, so I have put the link to that session. Please log into that session, and then see you soon virtually, maybe some other day. Thank you very much, and thank you very much, Dr. Shiromani, for your support.
Thank you, Dr. Chandana, for your support also.